Right, we have start from next 31st question in the next video. Now find the effective capacitance between A and B. See here in this question, here what is here, this first this part we have to see here. Here this is like a Wheatstone bridge. Now here for the upper part and lower part, this is the upper part, this is and the lower part, both are the Wheatstone bridge here. Wheatstone bridge means now it can satisfy or not. We know that Wheatstone bridge condition C1 by C2 is equal to C3 by C4. Now what will be there here? C by C is equal to C by C, means 1 equal to 1 means Wheatstone bridge is satisfied. So this is this middle capacitor is we eliminate. Here also we eliminate the middle capacitor. The remaining part value is equal to, here that is the remaining part is like this we are considered. Now the remaining part is coming like this. Here this is the remaining part we are considered here. This is the remaining part. Now this is the C and C. Now these two are in the series, these two are in the series. Now this series combination is A. This value we are getting here C by 2. Next this value we are getting as a C by 2. Now this is in the parallel combination. Now parallel combination means C by 2 is equal to, now what is here? C by 2 plus C by 2 is equal to C. Means this part is there. This part value is equal to, we are getting as a C. Now this part we are considering here. In this part also value we are getting as a C. Now below part is C, above part is C is we are getting here. This is we are considered as a above part is C, we are getting below part is C. We are getting here above part value is equal to C and below part value is equal to C. Remaining here middle one capacitor is there in between A and B. Now here this is we can read rather that diagram here. Now here this is in between A and B. One capacitor is already is there. Now above part value is equal to, we are getting as a, this above part is a Wheatstone bridge, below part is a Wheatstone bridge. That value, that resultant value we are getting as a C, and middle part value is the C, and next here also C. Here in between A and B we have to find the capacitor. These three are in the which combination here? Parallel combination is there. Parallel combination means C effective is equal to C plus C is equal to what we are getting here? 3C we are getting here. Which option is correct here? C option is correct. Next we go to the question number 32. Now we move to the question number 32. Now what is here? In the figure W1, WA represents a work done in taking a point charge from P to A. WB is a work done when charge is taken from P to B. WC is P to C. Now what is the work done value? Now here this is the equipotential surface. On the equipotential surface, when the potential difference is same in between A and P, in between B and P, and C and P, the potential difference is the, here what is the potential difference is the, here same is there. So the potential difference is the same means the work done is equal to work done for A, charge is taking from, here WA is the, what is here, work done taking the charge from P to A. Now what is here? VP minus VA. This is the work done. Now WP is equal to Q into VP minus VB. Now WC is equal to Q into VP minus VC. Point C. Potential difference we are writing. But potential difference VP minus VA is the same. VP minus VB is the same. VP minus VC is the same. Because that point, the charge is taken from P to A, P to B, P to C. That is the equipotential surface. The charge is taking on the equipotential surface means this value is same. Means Q charge also same. So what is we are getting here? WA is equal to WB is equal to WC. Means the work done also same. So which is option is correct here? B option is the correct. WA is equal to WB is equal to WC. Next we move to the question number 33. Now in an experiment, to measure the internal resistance of a cell by potentiometer is found to be balancing point at length 2 meter. Here that is when the cells are shunted by 5 ohm resistance. Now we know that here general formula we are writing here, V is equal to IR. Now KE, this is V can be written as potential gradient into length. The current can be written as E by R plus R into R. Here small r is the internal resistance. Now what will be here at the 2 meter length is given. The standard resistance is 5 ohm. Means here substitute here first of all this value K into 2 is equal to E by R plus R. Internal resistance value we have to find. Here external resistance is given. That is what is there, 5 is given. Centered by 5 ohm. This is into 5. This is given to the equation number 1. Now what is it? Next to here and when the length is 3 meter, the centered by 10 ohm. Next we are writing here length is given as the 3 meter. K into 3 is equal to E by 10 plus R into 10. Now this is given to equation number 2. So allowing these two equations, we are dividing equation 1 is divided with equation 2. What is we are getting here? 2 by 3 is equal to E also cancel. What is we are getting here? 1 by 5 plus R by 1 by 10 plus R into here 5 by 10. 5 by 10 we are getting here. 5 by 10 means 5 2s are here. E also cancel. 1 by 5 plus R. Now from this here we are getting as a 2 by 3 is equal to, it is coming into the numerator. Here 10 plus R by 5 plus R into 1 by 2 is we are getting here. Now 1 by 2 means 2 by 3 is equal to 10 plus R by 10 plus 2R. So what is we are getting here? 20 plus 4R is equal to 30 plus 3R. Now what is we are getting here? 4R minus R is equal to R. 30 minus here what is here? 20 is equal to R is equal to we are getting as a 10 ohm. Means answer which option is correct here? C option is correct. Next we go to the next question. Question number 34. Yeah, next we go to the question number 34. The network of resistors are constructed in the form of English letter A as shown in the figure. Then the effective resistance between A and B. See here. This is one part I am considering. These three are in the series combination. Series combination means these three part we are getting here. Here 3 ohm we are getting. This total is equal to series. Series means the resistance series combination value R1 plus R2 plus R3. Now what is getting here? R1 plus R2 plus R3 means 1 plus 1 plus 1 is equal to 3 ohm. Means this part is a, this is 3 ohm. Next what will be there here? This is a 1 ohm, this is a 3 ohm, this is a 1 ohm, this is a 1 ohm. Here 3 ohm and 1 ohm parallel. Next the total combination in the series. Now what will be there here? This is a, here what is I am writing here? Effective resistance between A and B. What is I am writing here? That effective resistance is equal to 1 ohm plus. Now this is 3 ohm and 1 ohm parallel combination is there. Parallel combination means 3 ohm into 1 ohm by R1 R2 by R1 plus R2 plus. Next this is series. For this combination is series, and for this and this is also series combination. So what is I am writing here? This is 1 ohm. Now what is we are getting here? R effective is equal to here 1 plus here what is here 3 by 4 plus 1. Now what is we are getting here? R effective is equal to here this is 4 plus 3 is equal to 7. 7 plus 4 is equal to 11 by 4 ohm. We are getting 11 by 4. Means these two are, this is when 3 combining 3 ohm. 3 ohm and 1 ohm parallel. That effective is that effective resistance what we are getting 3 ohm and 1 ohm. That is 3 into 1 ohm by 3 plus 1 ohm. That is series to 1 ohm and 1 ohm. That's the reason we are writing here 1 ohm. These two are 3 ohm and 1 ohm is a series is there. 3 ohm into 1 ohm by 3 plus 1 plus 1 ohm. Now 1 plus 3 by 4 plus 1 is equal to 11 by 4 ohms we are getting. This is a B option is correct. Next we go to the question number 35. The 3 long straight parallel or equally spaced wires carrying a identical currents as shown in figure. If F1 and F2 are net forces are 1 and 2 and 3. Now here the net force acting in between, there is attraction force is there. In between these two is repulsive force is there. Now the net force acting on F1, F2 and F3 we have to find here. For generally find the F1, F2 here force acting on 1 due to 2 and 3. Force acting on 2 due to 1 and 3. force acting on 3 due to 1 and 2. That values we have to find. That is the resultant force acting on the F1. That resultant force acting on the F1 we have to write here. That is F minus F2 is equal to, we are getting as F by 2. The resultant force acting on the second one is equal to F plus F is equal to 2F. Now resultant force acting on the third is taken as a here. What is here? F plus F by 2 is equal to, we are getting 3F by 2. Now which is the largest there? Here this is the, what is here? Which is the small here? F by 2 is the small. Which is the large here? 2F is the large. So what is we are getting here? We are getting here F2 greater than F3 greater than, what is here? F1. F2 is larger. Next what will be here? F3. Next what is here? F1. So F2 greater than F3 greater than F1. Here which option is correct here? A option is correct. Next we go to the question number 36. Now what is here? We find the total magnetic field. That is a magnetic field due to the two arcs are given. One is having the radius is R1, another one is having the radius is R2. Now both are acting. Now what is here? Inside the board, because of we use the, here this is the, here we use the thumb rule. When using the thumb rule, this is the magnetic field acting at O point is here. What is the inside due to this arc? Due to this arc, inside will be there using the thumb rule. Now what is here? From this here the magnetic field due to the semicircular arc. We know that formula mu naught I by, here mu naught I by 4R. This is the formula. Generally B equal to mu naught I by 4R. Now both of the magnetic fields are acting inside the board. Inside the board is acting here. That's the reason we are taking a magnetic field is equal to B1 plus B2. Both are acting inside the board. Now what is here? B is equal to mu naught I by. This is magnetic field due to this arc. This arc means radius is taken as R1. That is taken as a 4R1. Now this is a magnetic field due to second arc mu naught I by 4R2. Now what is here? B is equal to mu naught I by 4 is taking common. Remaining is 1 by R1 plus 1 by R2. Now what is we are getting here? B is equal to mu naught I by 4 into, this is R1 R2, R1 plus R2 by R1 plus R2 by R1 R2. We are getting mu naught I by 4, R1 plus R2 by R1 R2. Which option is correct here? A option is correct. Next we go to the question number, what is here? Question number 37. Now what is a magnet is in the form of the cylindrical of length of 10 cm, diameter 1.0. The magnetization is given. It's a magnetic moment we have to find here. Now magnetization, intensity of magnetization formula I equal to M by V. M is called as a magnetic moment. Magnetic moment is equal to I into V. But this is in the form of the cylindrical rod. Cylindrical rod means the volume of the cylindrical rod is taken as a pi r square h. This is the volume of the cylindrical rod. Now length and what is here? Diameter. Length nothing but pi r square L we can take here. Length is given. Now pi r square L. Now here this is a magnetic moment. Here magnetic moment. Here this is the, what is here? It has uniform magnetization. Intensity of magnetization is given 5.30 into 10 power of 3 into pi value is equal to 22 by 7 r value. That is R value is a diameter given. Radius means here 1 into 10 power of minus to 1.0 is given. The centimeters are converted into meter. By diameter given means radius means we have to divide with 2 whole square into length. Length is a 10 centimeter. 10 into 10 power of minus 2. When calculating this value, now we are getting the magnetic moment. That value is equal to 41.6 into 10 power of 3 Joule Tesla inverse. What is we are getting here? M is equal to 41.6 here milli. 10 power of 3 means milli Joule Tesla inverse we are getting here. This is called as a, here what is here? Magnetic moment. Right, this is a magnetic moment. Next here we go to the which option is correct here? C option is correct. Next we move to the question number 38. Here listen here, in the question number 38. Here this is the one small mistake here. B naught we have to give here. Now what is here? B is equal to the material placed inside a solenoid carrying a current among the following relations which are holds which holds good are, means which are the correct they are asking here. This is not correct. This is we know that relations, only two relations are there, that is B is equal to B naught plus mu naught m. Another relation, from this relation finally one relation we are getting here, chi is equal to mu by what is here, mu naught minus 1. These two relations are the correct here. Now what is here, this is the third and fourth, both are relations are the correct. Both are relations are the correct means which option is correct here? Here both are the relations, B third relation and fourth relation, both are the correct is here. So which option is correct here? C option is correct, 3 and 4 only. Right. Next we go to the question number 39. What is the question number 39 here? Now what is there? Two inductors are given, they are connected in parallel combination. What is the effective inductance formula? L1 L2 by L1 plus L2 is equal to 2.4. Next they are connected in parallel means this is the first two inductors are connected in parallel. Next 10 Henry when connected in series combination is here L1 plus L2 is equal to 10. Now what is here, just this L1 plus L2 value substitute here, L1 L2 by 10 is equal to 2.4. Now L1 L2 equal to 10. From this we find the L1 minus L2 whole square is equal to, we know that here L1 plus L2 whole square minus 4 L1 L2. Now L1 plus L2 whole square is equal to 10 square minus 4 into L1 L2. L1 L2 is equal to, what will be there here, L1 L2 is equal to, here we are getting 2.4 into 10 is equal to 24. Now we are getting 24. Now what is here, this value is equal to 100 minus here 96. Now this value is equal to 4. 100 minus 2, 4 4 is 16. Now 96 we are getting. So L1 minus L2 equal to 2. Here L1 plus L2 is equal to 10. Then solve for these two. Now what is it there here? L1 plus L2 is equal to 10. L1 minus L2 is equal to, what is here? 2 is there. Now what is we are getting here? L2 cancel. 2 L1 is equal to 12. L1 is equal to 12 by 2 is equal to 6. Any one equation we substitute here. L2 equal to, we are getting here 10 minus L1. 10 minus 6 is equal to 4. Means which option is correct? One is 6 Henry, another one is 4 Henry. Means A option is correct. Now this is the 6 Henry and 4 Henry. This is the question number 39. Next we go to the question number 40. What is the question number 40 here? See here. Now cylindrical rod, two coils are wound over the if the one of the inductance is given, mutual inductance is asking here. Here this is the M is equal to, we know that here K into, this is a relation between inductance and mutual inductance. Now here inductances are given, L1 and L2, and the mutual inductance we have to find here. Formula is M is equal to K under root of L1 and L2. For here what is here, for this is the K value we can take here 1 here. This is the correct, we are coupling this correct is there, K value take is 1. Now what is here, M is equal to K is the K value is 1. Now this value is taken as under root of L1 and L2. L1 and L2 each coil is having the inductance is 0.1 into 0.1 is equal to under root of 0.1 whole square. Now M is equal to, what we are getting here, 0.1 we are getting here, 0.1 Henry we are getting. This is the answer. This is the mutual inductance of the pair of the coil is there. Now this is value is 0.1 Henry we are getting. Right, here B option is correct. Next we go to the question number 40 is completed. Next we go to the question number 41. Now listen here, in this question, see here, the circuit is shown. The inductor used an ideal one. Inductor is ideal. Now inductor is, what is here? This is the inductor is there. That inductor is ideal. The current drawn from the battery when the switch is closed here. This is closed. What is the current drawn from the battery? Now what is here? This is asking. Now this is the inductor is what is here? Ideal is here. So there is no current is flowing in this resistance because inductor is ideal. Now what is here? Only 5 ohm, 5 ohm, two resistances are there. Now what is here? This is the EMF is 10 volts is given. Now resistances are in the series combination. So effective resistance is taken as a R effective is equal to 5 plus 5 is equal to 10 ohm. Next what will tell here? EMF also 10 ohm is there. So current, we have to find the current is equal to V by R. V by R means voltage is equal to 10. Now what is here? That is the resistance is equal to effective resistance is equal to 10. 10 cancel. We are getting here current is equal to 1 ampere we are getting here. That is 1 ampere is the answer. That is which option is correct here? C option is correct. This when we are inductor is idea, we can remove the resistance. Means no current is flowing in the 10 ohm of resistance. So it is neglected. Remaining resistances are considered. From this we are getting current is equal to 1 ampere. Next, we go through the question number 42. Now, what is here? AC circuit. The current is given. In this circuit, the current rises from 0 to peak value in time. Time is asking. Now, what is here? Current relation is given. I is equal to what is given here? 100 sine 2 pi. 100 sine what is here? 200 pi t. That is 200 pi t is given. 100 sine 200 pi t is given. That current I am comparing with I is equal to I naught sine omega t, or I is equal to I naught into, this is a general formula for what is here? AC current. Now this is what is here? 2 pi, here this is what is here? 2 pi nu into t. Now compare this one. Here 2 pi nu, t is same, 2 pi nu is equal to what we know that here 200 pi. 2 pi nu is equal to 200 pi. Pi cancel. Now what is here? 2 ones are 200s are. Now what is here? Nu is equal to 100. But what is asking here? Time is asking. Time is reciprocal of the frequency. So time is equal to t is equal to the current from 0 to peak value in time. T is equal to 1 by nu. 1 by nu means what is here? 1 by 100 seconds. That is which option is correct here? C option is correct. 1 by 100 seconds. Next, we go to the question number 43. The amplitude of electric and magnetic fields are related to each other. This is the direct question is there. Now what we know that here V is equal to R, C is equal to E by V. When amplitudes are considered, C is equal to E naught by V naught. E naught by V naught. But what is asking here? E naught. Here we can identify which relation is correct here. Here V naught is equal to what we are getting here? V naught into C. Means which option is correct here? B option is correct. Now E naught is equal to V naught into C. Right, this is the question number 43. Next, we go to the question number 44. An electromagnetic wave is emitted by charged particle. We at rest. First one is at rest, moving with uniform velocity. It is also not correct. Moving with an acceleration. Why moving with the acceleration? We know that already. Accelerated particles are electrons. Anyone? Accelerated particles are emitted the which wave here? Electromagnetic wave. That's the reason moving with an, that particle is moving with an acceleration. This is a question number 44. Next to question number 45. Listen here. Now a parallel beam of light is incident on a combination of convex lens of focal length f and concave lens of focal length f by 2. Two lenses are where the image is formed. The image is formed here. Where the image is formed is asking in this question. Now listen here. Combination of the two lenses. We know that effective. Now f effective we are writing here. 1 by f effective is equal to effective focal length 1 by f1 plus 1 by f2. Now what is here? 1 by f effective is equal to 1 by here focal length. First focal length is f we are consider. Second focal length is f by 2. What I am consider as a minus because of this is what is a concave lens. Now when I calculate this one, 1 by f effective is equal to, we are getting as a, that this is minus is coming here, 1 by f minus what is here, 2 by f, 2 is coming into the numerator. Now 1 by f effective is equal to, what is we are getting here, f 1 minus 2, 1 minus 2 is equal to what we are getting here, minus 1, here minus 1 by f. So f effective is equal to what we are getting here, minus f. Right, this is we are getting f effective. Now what is here? The image, where the image is formed. Here we use the lens formula here what is here 1 by f is equal to 1 by v minus 1 by u. But in the what is the given parallel beam? Parallel beam means that is we are object is at infinite distance. Now f effective we are consider here focal length 1 by f effective is equal to 1 by v minus 1 by u. 1 by minus f is equal to 1 by v minus 1 by infinity. 1 by infinity is 0. So what is we are getting here? F is equal to minus f. Here from this v equal to minus f we are getting here 1 by infinity is equal to 0. V equal to minus f means this is the minus we are getting means this is a virtual image. At which distance it can form here? Its magnitude. Magnitude we are considering means mod v is equal to mod of minus f. Means what is we are getting here? Magnitude is equal to f. But here minus indicates the virtual. But at a distance of v is equal to f, the image can be formed. Right. This is a C option is correct here. Next we go to the question number here 46. And equiconvex lens, radius is 10 centimeter is given. Focal length, the focal length of the concave mirror, the radius of curvature of the concave mirror is equal to the focal length of concave mirror. The focal length of the equiconvex lens is same as the focal length of the concave mirror. The radius we have to find here. Now first we have to find the focal length of equiconvex lens. Now focal length of equiconvex lens formula mu minus 1 into 1 by r1 minus 1 by r2. Equiconvex means same radius. r1 equal to r2 equal to what is the given here? 10 centimeter. 10 we are considered. But one take the positive, one is a negative is there. Now depending upon the incident ray direction, now 1.5 minus 1 into, now what is here? 1 by 10 minus of 1 by minus 10. Now what is we are getting here? 1 by f is equal to 0.5 into, this is 2 by 10 we are getting here. 2 ones are 2 5s are. Now what is here? 5 ones are 0.1. Now what is we are getting here? 1 by f is equal to 0.1. Now here 1 by f is equal to 0.6, f is equal to 1 by 0.1. 1 by 0.1 means 10. This is the focal length we are getting 10 centimeter. But this focal length is equal to the focal length of the concave mirror. Concave mirror focal length is focal length is same. Same means that is taken as a 10 centimeter. That is taken as a minus. That is we are getting the concave mirror. Now radius. Radius is equal to just magnitude is asking. We have no need of take the minus here. Just radius and focal length relation r equal to 2f. Means r into f is equal to 10. Now what is here? R is equal to how many centimeters here? 20 centimeters. This is the B option. Is the correct. Now next we go to the question number here. Next we go to the question number 47. Now the graph reflecting fringe width B against the distance D between the slits in Young double slit experiment. Here small mistake is there in the question, small given. Right. Now what is here? What is here? This is the graph deflecting fringe width against distance. Okay, right. Fringe width and the distance, that is the graph is asking in the Young double slit experiment. Here what is there in the Young double slit experiment? Fringe width formula beta is equal to lambda d by d. So this is the beta is called as a fringe width. Fringe width is which proportional here to the distance d. For the distance d, we are drawing the graph between fringe width and the distance d. Distance small d means that is the distance between the two slits. Now b is inversely proportional to 1 by d. When b is inversely proportional to 1 by d means the graph is a rectangular parabola. The graph is rectangular parabola. Which graph is in this rectangular parabola? This graph is called as a rectangular parabola. So which option is correct here? B option is correct. Why B option is correct means that is a graph is a here beta is inversely proportional to the here what is the distance between the two slits here. That is an inversely proportional means graph name is a rectangular parabola. The rectangular parabola graph is having which option here? B option. Next we go to the question number 48. Now, in the double slit experiment, what we have taken here distance d, distance between the two slits, the screen at a distance d. If the maxima is formed just opposite to each slit. Now, what is the order of the fringes formed? That is the question is asked here. Now, what will take two slits here? This is a S1, one is a S1, another one is a S2. Two slits are considered, S1 and S2. Now this is a screen. The screen distance is D is given here. Now the distance between the two slits, the center of these two, is taken as the D. From center to the, that is the maxima is formed at it opposite to the any one of the slit. Any one of the slits, the total distance is D. This distance is becomes to be what is there, D by D. Means that is a here maximum formula is there. Maximum nothing but a bright fringe. Bright fringe formula is x m. We are consider r x n is equal to, we know that formula. The slits are separated by distance d. Maxima is just opposite to the order of the fringes. The order of the fringes was put here. Xn is equal to n lambda d by d. This is the distance from the central maxima. Now what is here? Distance from the central maxima is what is here? D by 2 is say. D by 2 is equal to n lambda d by d. Now what is here? N is required. Order is asking here. N means order. N equal to what is here? D into d. What is here? D square by here. What is we are getting here? 2 lambda d is we are getting here. D square by 2 lambda d. Which option is correct here? D square by 2 lambda d means here A option is correct. That is order is asking in the problem. Next we go to the question number here 49. Now the work function of the three metals A comma B comma C are WA comma WB comma WC. They are in the decreasing order. Decreasing order means WA less than WB less than WC. Means WC is large. The correct graph between the stopping potential and frequency. When graph between the stopping potential and frequency, always we are getting the straight line. But in the observe here, the C and D option, the straight lines are not there. So C option is wrong and D option is wrong. Directly we can conclude that. But in the A option and B option, because these two, why C and D options are wrong? Because they are not getting, they are not straight lines is there. Here when drawing the graph between stopping potential and frequency, we get the straight line. This is the Einstein formula is represents, Einstein equation represents the straight line. So these two are the wrong. Which is the correct here? Which is the correct means when the this is a work functions having the C is a large means stopping potential also large for the C. So stopping potential of A and stopping potential of B is stopping potential of C. Which is here stopping potential of C is large. Means where the stopping potential in this graph C stopping potential is large. Next to B, next to A. That's the reason which option is correct here? B option is the correct. Next we go to the question number 50. Now what will take here question number 50? A photoelectric cell is illuminated by a point source of 1 meter away when the source is shifted to 2 meter. Here listen here, first intensity is directly proportional to 1 by d square. Now intensity is 1 by d square means I1 by I2 is equal to d2 square by d1 square. Now intensity. Now what is here? Shifted to 2 meter is given. Now what is here? I1 by I2 is equal to 4 by, this is d2 is a 2, d1 is a 1, 4 by 1, 1 square is equal to 1, 2 square is equal to 4. So intensity I2 is equal to what we are getting here? I1 by 4. Means when the distance is increases, intensity is 1 by 4. Intensity is 1 by 4 means the emitted electrons also, the emitted electrons are depends upon the intensity. So emitted electrons carries 1/4 of the initial energy. This is around here. Each emitted electron carries half of the initial energy. This is around number of electrons are emitted as a quarter of the initial number. Quarter of the initial number by saying that intensity is depends upon the number of electrons. Or number of electrons are emitted is depends upon the intensity. So that's the reason intensity is 1 by 4 decreases the 1 by 4th part. So number of electrons emitted also decreases to 1 by 4. That's the reason which option is correct here. Number of electrons emitted is a quarter of the initial number. This is a 50 question. Next we go to the question number 51. The wavelength of H alpha line in the Balmer series of hydrogen atom is lambda. The wavelength of the same line in doubly ionized lithium. Means your wavelength formula from the Rydberg formula here 1 by lambda is equal to r z square into 1 by n1 square minus 1 by n2 square. Same line is means n1 and n2 values are same. So here 1 by lambda is depends upon the z square. 1 by lambda is depends upon the z square. So 1 by lambda is depends upon the z square means 1 by lambda is directly proportional to the z square. So from this we are writing as a here this is the lambda 1 by lambda 2. These two are inversely proportional. Inversely proportional means z2 square by z1 square. Here for the first hydrogen atom is given. Hydrogen atom wavelength is lambda. Next we have to find the lithium atom. Lithium atom is taken as lambda 2. Here Z2 means the atomic number of the lithium. Lithium is equal to what will be there here atomic number is 3 square. Hydrogen Z1 is the atomic number of the hydrogen, that is 1 square. So what is we are getting here lambda by lambda 2 is equal to 9 by 1. So lambda 2 is equal to lambda by 9. So which option is correct here? A option is correct. Next here this is a 51 question. A option is correct. Next, come to the question number 52. What is the question number? The ratio of energies of hydrogen atom in second and third excited states. The energy of the electron in hydrogen atom is 13.6 electron volts by n square. En is equal to minus 13.6 electron volts by n square. So what is I am writing here? Energy of the third and second and third excited states. Second and third excited state means second excited state n value is equal to, that is n1 equal to I am considered as a 3. Second excited state. Third excited state means n2 equal to 4. Now from this formula we are writing here energy En1 by, here this is En is inversely proportional to the 1 by n square from this formula. Now En1 by En2 is equal to what is I am writing here n2 square by n1 square, reciprocal. Now what is I am writing here En1 energy ratio is asking En1 by En2 is equal to n2. n2 is equal to what is here 4 square by n1. n1 is equal to 3 square. So what is here 16 by 9. 16 by 9 means what is here 16 is to 9. Which option is correct here? A option is correct. Now second excited means n value take the 3. Third excited state means this n value takes the 4. Don't confuse them. Next we come to the question number 53. Now a radioactive isotope may emit alpha, beta and gamma rays simultaneously. Here both alpha and beta are simultaneously. Alpha gamma or beta gamma. Protons, alpha rays and gamma rays. Generally we thinking that in this question radioactive isotope we are not here seeing the isotope here. When the radioactive element, we are thinking radioactive element. Radioactive element is emit the alpha and beta and gamma simultaneously. This option is correct for radioactive element. But here what is here? Radioactive isotope. Radioactive isotope does not emit the alpha and beta and gamma rays does not emit the simultaneously. It is the here means sometime here radioactive isotope is emitting alpha or gamma or beta or gamma. It cannot emit the alpha and beta and gamma simultaneously. But radioactive isotope is does not emit the alpha and beta and gamma rays simultaneously. But radioactive element is emit the alpha and beta and gamma rays simultaneously. When element is given, this option is correct. When isotope is given, which option is correct? Here C option is correct. Alpha gamma or beta gamma. Right. This is the question number 53. Next we go to the here what is here question number 54. Now the ratio of the average life of half-life to the ratio of average life to the half-life. That is the ratio is asking here. Here average life formula here tau is equal to 1 by lambda. Now half-life formula 0.693 by lambda. Now the ratio is asking here tau by T of is equal to what is here 1 by lambda by 0.693 by lambda. Lambda cancel means 1 by 0.693. 1 by 0.693 value is equal to 1.44. The ratio is how much we are getting here? 1.44. This is the ratio between the what is the average life and the half life. That is we are getting 1.44. Next we go to the question number 55. In the question number 55, see here a deflection layer in a junction diode consists of. The deflection layer in the junction is consist of means this is a here what is a p-type semiconductor, this is a what is a n-type semiconductor. Across the junction when the holes are moving from what is a p type to n type. The electrons are moving from n type to p type. Across the junction, it can use the here positive, here this can use the here negative ions. Here n type electrons are use the positive ions. Means across the junction it can use the negative and positive ions. Negative and positive ions are they are not moving here this side and this side. So that's the reason these are called as a which ion here immobile ions. This is our question number 55. Next question number 56. The current I through the 10 ohm resistor in the circuit shown in the figure. Now listen here. This is the positive terminal, this is a negative terminal. This is a p type, n type. This is a p type and n type in the diodes. We can observe in the diodes. Now positive connected to n type means negative. Positive connected to negative means it is in the reverse bias. Now we have negative connected to negative, positive connected to positive means forward bias. This is the reverse bias means that can be neglected. The current is very less, so neglected. Here only this is a here this is a neglected. This part is totally neglected. That part is totally neglected means remaining is what will be there here. Remaining is redrawing that diagram. Now what is here remaining is remaining here diode. Here this is a now what is here 15 ohm is given. Now this is what is here 10 ohm is given. This is a 2 volt. This part is we are neglecting. Why neglecting means this diode in the which bias here reverse bias. Right, that is in the reverse bias, so we are neglecting. Remaining is we are drawing this diagram. Now what is here? These two are in the series combination. These two are in the series combination means R effective is equal to 15 plus 10 is equal to how many ohms here? 25 ohms. Now we have to find the current here. Current is asking here. Current I is equal to V by R. That is the voltage is given. How many volts here? 2 by 25. 2 by 25 means we are getting 0.08 we are getting. 0.08 means how many milliamperes here? 80 milliamperes. Means which option is correct here? D option is correct. Next we go to the question number, what is here? Question number 57. Now the skywave propagation is suitable for radio wave of frequency. We know that here skywave propagation is suitable for the frequency. Generally know that is here 2 megahertz to 30 megahertz we are considered. That is the skywave propagation. For the skywave propagation, radio wave frequency suitable is how much here? 2 megahertz to 30 megahertz. Generally we are considered. But in the option near about we are considered as what is from 1 megahertz to 30 megahertz. Here 20 megahertz is a very small. Here 80 megahertz it is also not correct. This is also not correct. Means near about what is the which option is correct here? 1 megahertz to 30 megahertz. Because radio wave frequency is suitable for 2 megahertz to 30 megahertz. That's the reason here C option is correct. Next we are going to the question number 58. A TV tower of height 150 meter. Now TV tower of height 150 meter. What is the population covered by the TV tower? If population density of the TV tower is given 10 power of 3 kilometer, radius of the earth also given. Now what is the first distance covered by the signal? That formula is D is equal to under root of 2HR. Now that is D is equal to what is here? This is 2 into H. H means height. Height of the tower is equal to 150. Radius is equal to 6.4 into 10 power of 6. This is we are getting here. D is equal to under root of 300 into 6.4 into 10 power of 6. Here 6.4 into 10 power of 6. Here 6.4 into 3. Here this is we are getting 19.2. Means 19.2 means 2 zeros, 1920. Here about we are getting under root of 1920 into 10 power of 6. This is the distance covered by the signal. Now what we have to find here? The population density is given. Population covered by the TV. Means population density is equal to formula. Population density is equal to population population covered by the TV by area. This is the formula. Now population covered by the TV. Now what is here? Population covered by TV. Population covered by TV can be written as population density into area. Population density into area. Now the population density is given already. Population density around the TV tower is 10 power of 3. That is 10 power of 3. Now that is the area. Area is taken as a pi d square. Now pi d square means 10 power of 3 into this value is equal to 22 by 7 or 3.14 we consider. Now under root of d square, d value is equal to d square. D value is equal to under root of 1920 into 10 power of 6. Now this is d square means square under root cancel 1920 into 10 power of 6. When calculating, we are getting this value is equal to 6.288 lakhs. Which option is correct here? A option is correct. This is question number 58. Next we go to the question number 59. Now two bodies M and N of equal masses are suspended from the two separate mass spring constant K1 and K2 respectively. The two bodies are oscillate vertically such that their maximum velocities are equal. The amplitude of vibration is asked. Here maximum velocity formula generally V max is equal to A omega. Here maximum velocities are equal means V max 1 is equal to or V max M body is equal to V max N body. Both are the given. Now the spring constant is also given. Now V max is equal to what is the formula A omega. First body A1 omega 1. Second body is equal to A2 omega. Here ratio of amplitudes is asking means A1 by A2 is asking. A1 by A2 is equal to omega 2 by omega 1. Omega 2 by omega 1 means here this is the two bodies are equal masses are given. Equal masses are given. Here first one is omega is equal to we know that formula under root of K by M. So here omega is equal to first to second one. For the second body, the spring constant is given K2, mass is the same means M. For the first body, spring constant is K1, mass is the same means M. Now what is here? M cancel. Now what is we are getting here? A1 by A2 is equal to omega 2 by omega 1 is equal to under root of K2 by K1. And which option is correct here? D option is ratio of amplitudes is under root of K2 by K1. That is the ratio of amplitudes of M body and N body. That is we are getting here under root of K2 by K1. D option is correct. Next to last question. Here what is the last question here? Now two small balls carrying a charges 9 microcoulomb and minus 4 microcoulomb attract each other with a force F. Now that force I am writing here. F is equal to 1 by 4 by epsilon naught. Here with force. Now what is here? Here the distance we can consider as a d. That is the one is a 9 microcoulomb magnitude. 9 microcoulomb minus 4 microcoulomb means magnitude is taken as 4 microcoulomb. Micro means we are writing here 9 into 10 power of 6 into 4 microcoulomb means 4 into 10 power of minus 6. Here magnitude I am writing 4. Here minus becomes to be plus. Here r square. Force is first taken as a by r square. Now this is I am considered as a F1. Next what is here? Minus 5 microcoulomb is added to each of one. Each one of them. Each one of them means we are adding here for the 9 microcoulomb we are adding 5 microcoulomb. The total charge what is we are getting here? New charge. I am taken as a new charge what is we are getting here? This new charge is equal to 4 microcoulomb. One is. Now another one is 5 microcoulomb is added to minus 4 microcoulomb. Means what is here? Minus 4 microcoulomb minus 5 microcoulomb added. Just you are confusing here. Added means not taking the plus means plus into minus again getting the minus. Here also plus into minus minus. Here this is a 9 microcoulomb. Now in this the force we are writing here. Now new charges are 4 microcoulomb and minus 9 microcoulomb. When adding to the how much charge here? Minus 5 microcoulomb charge is added. Now the force between these two charges I am writing here. 1 by 4 pi epsilon naught. Magnitude is considered. Here what is here? First force F1 is equal and considered as a F. F is given. That is F considered. Now 1 by 4 pi epsilon naught 4 into 10 power of minus 6 magnitude means 9 into 10 power of minus 6 by r square. See here. This equation and this equation we can observe here. This is 4 into 10 power of minus 6, 4 into 10 power of minus 6. 9 into 10 power of minus 6, 9 into 10 power of minus 6. This F1 equal to this value is equal considered as F already given. So this is also same as this equation. Equation 1 and equation 2 are both are the same. That's the reason we are writing here F1 equal to F2 is equal to that F1 equal to F, F2 is also equal to F because equation 1 and equation 2 are represent the same values. So F1 equal to F2 equal to F. Means F2 equal to what is we are getting here? F. So which option is correct here? A option is correct. Okay, thank you.